Hello, good evening. So I hope you can see me and hear me clearly. So this is our second YouTube live regarding organic chemistry. Organic chemistry, we started IUPAC Nomenclature. First day we did introduction for the organic chemistry. Thereafter we started IUPAC Nomenclature. So this is the second day. So through the YouTube live, what we are doing actually, we will complete the nomenclature of organic compounds. Then at the end of these live sessions, actually, you can then name any organic compounds given in the exam paper according to our syllabus. So I plan to do one more session for the past paper question discussions regarding the nomenclature part. Just knowing theory is not enough. We should know how to apply that theory in the real questions. Therefore, one more session will be there for nomenclature part. It is the completely discussion of past paper question. That day also I told you, then this is parallel to our physical class. Actually, in physical class, then we started the isomerism topic also in organic chemistry. So parallel to this, we already started some other sections in organic chemistry. Then through the YouTube live, we will do this complete IUPAC nomenclature part. And in future, I supposed to do some other lives also regarding the chemical and physical property of alkane will be discussed within the live. And not only alkane, then some other functional groups, not all, but some functional group will be discussed here. Meanwhile, we continue the other section in live physical class. I'm doing this one in this manner. Then we can cover this or finish this organic chemistry part quite early. That's why I'm doing this one. Okay. Right. Let's start today's lesson then. Today, actually, the thing is this one, I planned to do this live last Saturday, but there was some kind of technical issue. I tried to figure out, but I couldn't figure out it. That's why I had to postpone this one to today, Wednesday, right? It's okay, then we are doing anyhow this one. Yes, last week I gave you a homework. I hope all of you have done it and waiting for the answers. I told you that day you should do that one because that is the starting point for the second day live. I hope all of you have done it. Okay, let's go to the homework and then start the lesson. And next thing, I hope all of you have the tute. It was there. Those who don't have it, it's there in the chat. So not chat actually, description. I'm not going to share this because I hope you have it. What I asked you to complete actually the question number 2, identify the main carbon chain and number them correctly in the following compounds. That's what I think I asked you to do. Question number 2. Hope all of you have done it. So if I just briefly, explain what we discussed last week under the IUPAC nomenclature part. Actually, we did, I explained 3 methods, 3 steps. I told you then, when you are going to name an organic compound, you have to follow a set of rules. It's not kind of 2 rules, 3 rules, 4 rules like that. In the case of organic chemistry, there is a large number of rules you have to follow. Therefore, it is quite complex because of the number of rules you have. But then I asked you, I promise you to explain all these rules under 4 steps. What was the first step 1? We learned that one. Step 1, identify the class. Identify the class. That's what I asked you to do. And that day I explained how to identify the class. Based on the functional group, you can identify. The given compound has a carboxylic acid, the given compound has ether, the given compound has ketone, how to separate ketone from ether, everything we discussed last time. That's the first step. Identify the class of the compound. What is the step 2? Step 2 is identify main carbon chain. Main carbon chain. That's the other step I asked you to do. Step 2, identify the main carbon chain. I hope you can see everything. So under the, I mean, once you are going to identify the main carbon chain, then I told you, then it's not easy. Because for a given compound, there can be more than one carbon chain. Carbon chain means consecutive carbon atom, I explained. But for a given compound, there can be more than one carbon chain. But only one is main carbon chain. In that case, not three, actually four requirements I explained. First thing, functional group must be present. Second thing, double, triple should be there. If it is available, then it should be there. Third, maximum number of substituents should be there. Fourth, maximum number of carbon atoms should be there, or the longest carbon chain should be there. But I told you that day, all the four things sometimes not satisfied. Once you go to the first requirement, then functional group, then you have already selected the main carbon chain. Then no need to consider the other. I know that some of you do some common mistakes. So first of all, you select the longest carbon chain. It is wrong. Hari. First of all, you have to pay attention to functional group. Then you have to pay attention to the double, triple, if available. Then you have to pay attention to the substituent, right? Then only you have to go to the longest carbon chain. So I don't write it here. You know that one. Next thing, step 3. What was step 3? Step 3, number this carbon chain. Number this carbon chain. Number carbon chain. Under this, I told you, you're going to assign number for each and every carbon atom in the main carbon chain. But again, we are doing the nomenclature of aliphatic compounds. Aliphatic compounds have two open ends if it is not cyclic. If it is acyclic, you have two ends. Any carbon chain, you have two ends if it is not cyclic. Then one can start from this end, one can start from this end, but there is a proper way to select the correct end to start the numbering. In that case also, I explained 3 requirements. You remember that one, eh? Lowest possible number should go to the functional group. That's the first thing you have to check, right? Next thing is the lowest possible number should go to the double bond or triple bond if available. That's the second thing you have to check. And finally, the lowest possible number should go to the substituents. That day I explained even what is substituent and everything we discussed. So that is how we number main carbon chain. So these 3 steps are the most important thing, because if you do any mistake here, you end up with the wrong answer. Let's go to then step 4. But before I go to step 4, there is one more step. It's simply naming the compound. Before I go to step 4, then I will go back to the homeworks and then complete it. Because you are waiting for that. You are waiting for the homeworks. Okay, identify question number 2 I'm talking about. Then in question number 2, I ask you to identify the main carbon chain and number them correctly. But first question is really easy, because only one chain available, that should be the main carbon chain. 4 carbon atoms available in this chain, and only one chain is there. Therefore, this must be the main carbon chain, nothing else. And then I ask you to number it. And here also, then it is very easy. There is no any double bond. There is no any functional group. I mean, CC double bond everywhere. No functional group, no double bond, no substituent. In that case, you are free to select this end or this end to number it. You start from left-hand side, you start from right-hand side, both are correct. Let's go to second one. Second one is, then it has something else. Right? It's given like CH3, CHBr. But I take Br here in this manner. Then CH2, CH3. Look at this. If you have any doubt, you can ask, right? Where is it? Sometimes I can't find the file because so many. Hurry. Okay, I got it. Hurry. Then here, how do we number it? And main carbon chain, it's okay. Only one carbon chain available. That must be the main carbon chain. It's clear. Thereafter, numbering. How do you find this Br as a substituent or functional group? I told you then if halogen is available, that is then actually a functional group because it is alkyl halide, alkyl bromide here. But in the case of nomenclature, remember, alkyl halides are considered as derivatives of alkanes. Therefore, in the case of nomenclature, this Br is identified as a substituent, not functional group. Substituent. Correct? Okay. Then Br is substituent. Now, there are two possibilities to number it. Number 1, 2, 3, 4. Red. And one can start from this number 1, 2, 3, 4. Green. So which one is correct? Then we go to the priorities. Functional group, I told you there is no functional group here. In nomenclature, Br is not functional group. It's a substituent. Double triple, there is no double triple. Then we go to the substituent part. Hurry. Br is the substituent. That carbon has number 2 or number 3. If you follow red method, I mean the red numbering, it's number 2. If you follow green numbering, it's number 3. So there is a rule. The substituent should have lowest possible number. Lowest possible number. Then what is out of 2, 3 lowest? Yes, of course. It's red one. Eh? Green one is wrong. In the second case, numbering is in this manner. Go to the third compound. I'm doing this quite fast because we need to finish everything today. It's given CHOH. Hurry. CHOH, CH2, CH3. This is how the compound given. Again, it is easy to select the main carbon chain. First, identify the class. Since OH available, this is what? This is alcohol. OH is functional group, not substituent. It's functional group. So we identify this as alcohol. Right. Then we should give the priority to alcohol. OH functional group. Right. Then this is the only carbon chain available. That must be the main carbon chain. Then we do the numbering 1, 2, 3, 4, and green 1, 2, 3, 4. Again, you see. In numbering, I ask you to give the priority to what? Functional group. Functional group. So functional group is OH. It has two options, one thing 2 and other 3. Lowest possible number for functional mean. Red one is correct. Green one is wrong. Fourth one it's given CH2 double bond, thereafter CH, then again CH2 and CO. I draw it in displayed formula. It's ketone, you see. Classes we discuss. Hurry. This is the only carbon chain available. Then that should be the main carbon chain. It is easy. Now you see, identify the class. Class is, there are two, ketone, alkene, but you know priority, ketone. If you have more than one functional group, I ask you to follow what the priority is. I gave you that order, you remember that. So ketone has more priority, so it's a ketone. Means this is the functional group available, C double bond O. C double bond O, actually these C, all the parts should be there, right? That must be in the main carbon chain. Okay, it is there. Then we go to the numbering. You see the numbering, number 1, 2, 3, 4, 5. Another way, number 1, 2, 3, 4, 5. Then what could be the correct number in here? Red or green? Can you put that answer in chat? My question is, what could be the correct name? Right. Actually, it is useless to ask the question because 20 minutes delay is there. In that case, then sometime you answer, but I have to wait 20 minutes, so it's not practical. Therefore, I just continue. Correct. Yes. Out of these two, number 4 goes to the functional group, number 2 goes to the functional group, but minimum possible number should go to the functional group. According to that, here green one is correct, red one is wrong. It seems like at the beginning, these are very simple things, very easy things. Then why do you waste time by discussing? No, this is the foundation. Only if you have this foundation quite as strong, you can develop the other concepts with the confidence. That's why I am explaining these things in detail and then doing again and again through the questions. That is really important. Fourth one, you got it. Now we move to the fifth one. Fifth compound is given like this. I hope you can see. This is the compound CH3, CH, again CH2, CH3 here. Next you have CH2, functional group CONH2. That's the compound given. Then go to the first step. So what is first step? Identify the class of the compound. Then you have alkane part here, but CONH2, you know, this is amide. This is amide. We identify this as amide. Amide means the functional group is this part. This part is the functional group. Okay. That must be in the main carbon chain. Okay. Since then step 2, identify main carbon chain. In this compound, there are several possibilities. You see, one from here to here, other from here to here. Next one is from here to here. There are 3 possibilities for the main carbon chain. But then I told you, first thing is functional group. Then functional group must be present in the main carbon chain. Then I told you this one is the functional group. Then you start the main carbon chain from this carbon and come to this junction. Last day also I told you, when you meet a junction, stop there. Junction mean you have several options. Stop there, think about it. If you go straight, after the functional group, what's the next priority? Double, triple. If you go straight, will you meet double bond? No. Triple bond? No. If you go up, will you meet double, triple? No. That's all. The next, substituents. I explained last day what is substituent. So if you go straight, will you meet substituent? No. If you go up, will you meet substituent? No. Then again, we don't need that one. Then we go to the last one, longest carbon chain, maximum number of carbon atoms. If you go straight, you meet only 1 carbon, but if you go up, how many carbon atoms? 2 more carbon atoms. Therefore, if you go straight, then you have total 1, 2, 3, 4 carbon atoms in the main carbon chain. But if you go up, you have 1, 2, 3, 4, 5. Then maximum number of longest carbon chain. Therefore, this should be your main carbon chain. We selected main carbon chain also. Step 2 finished. Step 3 then, number carbon chain. When you're going to number the carbon chain, again, we give the priority to functional group. This is where you get functional group, CONH2. Then you know, that is where you start numbering actually. In the case of amide, always carbon atom becomes 1. I'll give those functional groups. There are some functional group where the carbon atom, the functional group carbon becomes then number 1. What are those things? Those are carboxylic acid, ester, acid halide, amide, aldehyde. Those things actually in these functional groups, always number 1 goes to those functional group. I list out, then it will be easy. Remember that one. What is it? Carboxylic acid, ester, carboxylic acid, ester, acid halide, amide, and aldehyde. In these cases, in these 5 actually, always functional group carbon becomes number 1. Better remember in that manner, then it will be easy. So it is amide. Amide is here. Then that number, that carbon should be number 1. No need to think about the other option. Thereafter, this should be number 2, number 3, number 4, number 5. No issue. This is the main carbon chain and this is the correct numbering. main carbon chain and correct numbering. So any doubt you have, then better you ask, right? Yeah. Better you participate this live actively. Otherwise, you will sometime sleepy after about several, I mean, maybe 1 hour, 2 hours, then you may sleepy. But once you participate this one actively, like giving the answers in the chat actively, then it will be quite interesting for you to continue this live, right? Next thing, then sometime you can't type it. Okay, it's okay. Then at least you have to give answer. I mean, say it loud. Wherever you are now, maybe you are in the room now, attending this class, it's okay. Once I ask a question, then just say it loud, right? So your mother, father sometime will come quickly to your room and check whether you are going mad or something because you are shouting. But soon they will realize that you are studying interactively, actively. So that is a good thing. So this is how we get the answer for question number 5. Let's go to question number 6. I will erase the first part here. We are talking about question number 2. Fifth one completed. Let's move to sixth one. Sixth one is given the compound structure given like this: CH3, CH. Upper part is CH double CH CH3. Thereafter, here you have CH2, COOH. You see carboxylic part. Ne? Identify the class. Always go to step 1. Identify the class. Class is carboxylic acid. No issue. Then this is your functional group, right? Then identify main carbon chain. So when you identify main carbon chain again, if these 5 given, if the compound is one of these 5, start from that functional group. These are quite easy methods. Start from that functional group. Carbon is the functional group. I mean, carboxylic. That carbon I start. Then come to a junction. Yes, this is where we have junction. Once you come to junction, go for the other requirement. Double, triple. Yes, we have. Then definitely we should move up. This is your main carbon chain. Once you identify that as main carbon chain, remember this is a substituent. This CH3 group, it's a substituent. It is attached to the carbon in main carbon chain, but it's not hydrogen, it's not functional group, so therefore it's substituent. Right, then numbering. Numbering again, I told you, if you have one of these 5, start from that, okay, that carbon. So this is number 1, number 2, number 3, number 4, number 5, number 6. That's the correct numbering for 6th compound. You see how easy once you understand the concept. Let's move to 7th part. 7th one. Yes. 7th compound is given like this: CH3, CH double, COH. After that, it's given CH2, CH3. This is the compound given in 7th question. Again, main carbon chain easy because only one carbon chain available. That's the main carbon chain. Identify the main functional group. Right here, alcohol. Alcohol means the functional group is OH. Now, OH, you see, it is somewhere in the middle here, not at one of this end, not like these 5. So the functional group like then alcohol, OH, sometime NH2 amine, sometime ketone, C double bond O, they are not like this. They can be anywhere in the main carbon chain. In this case, I told you number 1 goes to these things definitely. In this case, I told you the main carbon chain start from this functional group, but in this case, we can't say like that. In the other cases, right? Alcohol, then we can't say number 1 goes to this. It can't be, because that carbon somewhere in the middle, right? Carbon chain start from one of these 2 ends. Therefore, number 1 can be this carbon. Then according to that, 1, 2, 3, 4, 5. Oh, number 1 can be this carbon. According to that, 1, 2, 3, 4, 5. Okay, then without explaining, before I explain it, I ask it, what could be the correct one, red or green? Right. Yes. So it is then what? Green. What is the special situation in this compound? Functional group has same number. You see, if it is green one, number 3. If it is red one, number 3. So when you get same number for the functional group, then go to the next priority. Next priority, double bond, triple bond. Okay? The carbon which starts double bond should have lowest possible number. The carbon which starts double bond or triple bond. All right. So if it is red one, you see third carbon atom starts double bond. If it is green one, you see second carbon atom starts double bond. Then which one is correct? Two options available. What is it? 3 or 2. Then lowest possible number mean green one is correct. Red one is wrong. So in question number 7, this is how we have it. Green one is correct. Right. Let's move to last one. I have given only 8. That is pretty enough to revise it and then get the point, understand the point. Right. 8th one, it's a bit complex, I think. Yes. These are exam standard one, but still you can answer the question because you know the basic. CH, you have CHO here. Thereafter, you get CH2, next CH, again CH3. Down you have another part, it's CH, double bond CH2. Hi. Look at this. First, identify the class of the compound. You see CHO. CHO group is what? This is the functional group you have. And CHO is for what? Aldehyde. So this is identified as then aldehyde. Okay, that is aldehyde. Then check whether it is available. I mean, it is one of this functional group. Then it is easy. Yes, of course, aldehyde. It is one of this functional group. I mean, one of this category. Then I told you main carbon chain, start main carbon chain from the functional group. Okay, then I come to this junction. Then where to go? Then it's very clear. Then thereafter we check for the double. This is where double bond available. Then definitely I should go down like this. I mean, come to left, I mean, right hand side. Thereafter, definitely again junction is there. Straight or down. Definitely we should go to down because double bond must belong to main carbon chain. So this is how you select your main carbon chain. Doesn't matter how complex the compound is given, just follow these 3 steps. You end up with the correct name easily. Few seconds, you can get the answer. Okay, that's why I took time and then explain it in detail. CH3 becomes substituent, this CH3 becomes substituent, right? Next, the numbering. Again, it is easy because it's one of this functional group. I ask you to start numbering from that carbon. 1, 2, 3, 4, 5, 6. No need to look for the other option. If the functional group is one of this, I mean the class one of these 5, that is where you have to start numbering. Got it? I hope you understood it. Mm-hmm. Oh, I can't see the chat. Right. I hope you understood the first part without any doubt, without any difficulties. Good. Let's move to then fourth step. Let's move to the fourth step. Fourth step is then naming the compound. We have done all the initial works successfully. Next part is to then name the compound. That's the last thing. Step 4, naming the compound. I think we got the note. We wrote everything. So better you write in the printed note. I have given some spaces to write the note. Better than you write step 4. Write the step 4. Name the compound. Step 4, right? Name the compound. Name the compound. Hurry. Step 4. Name the compound. So when you are going to name the compound, I divide the name into two parts. One is the name of the substituent, the other part is the root name. I divide that name into two parts. So first part is then names of substituents. Next part is then a root name. Why I first place the names of substituent? Because that's what we write first. If the compound has a substituent, that's what you name first. That's what you write first. Then only you go to the other part. So the thing is this one, I mean, once you look at the name of the organic compound, that name should give the complete information regarding the compound. That means how many carbon atoms available, whether double, triple available, if it is available, where is it, how many substituents available, what are the type of substituent available, what are the places of substituent, what's the functional group, where do you find it. So complete information should be there within the name. Name gives complete information, like your name represent yourself. Is that? Think about it. Because your name has some meaning. Do you work according to that meaning? Names of substituent and root name. In the case of names of substituent, in the printed note, somewhere I have given some substituents and the names for them. These substituents have specific name. As example, these are quite famous ones. Cl, substituent, name chloro. Br, substituent, name bromo. Like that. I, substituent, name iodo. Like that. Other than that, what? Cn, substituent, name cyano. OH, substituent, name hydroxy. Like that. NH2 substituent, name amino, right? CH3 substituent, name methyl. C2H5, or in other words, CH2, CH3 substituent, name ethyl. So likewise, NO2 substituent, name nitro. So there is a specific name for the substituent. First thing, you should know them. You know, then someone can say, no, OH is functional group. Yes. Sometimes it acts as functional group, sometimes it acts as substituent. It depends on the other functional group available. If the other functional group has higher priority than OH, alcohol, then OH is substituent. Right? That's the first thing, names of substituent. There is a specific name. The other thing is, there is a certain place for substituent also. You can't just write chloro. You don't know where you put then Cl. You should specify the position of this chlorine part. As example, if I take this example, look at this. Right, I write it here. I need some space. Let's say you have CH3, CH, CH, double bond CH2, CH, Br, CH2 COH, like that, this type of compound. Okay. Then look at the step one. What is the step one? Identify the class. So when you look at this functional group, you identify this as what? Aldehyde. Is the functional group available, right? Then if it is available, you know, aldehyde is one of that 5 classes I gave you. Then identify the main carbon chain that definitely start from this carbon and come to this junction and go up because it's double bond. Next, numbering again, I told you definitely you should start from the functional group in those 5 section classes. Then 1, 2, 3, 4, 5, 6. That's how we number it. Then first 3 steps, okay. Next, I asked you to write the name of substituent. Then what is this? This becomes now substituent. What is this? This becomes now substituent. And then what are the names? You know, Br name is bromo. But can I write just bromo? No, wrong. Why? You need to specify the position of bromine. That means the number of carbon atom to which bromine attached. So what is that? Number 3. Ne? So it should be 3 bromo. Can I write just 3 bromo like this? No. There is a way to separate the number and word. 3 small line dash and bromo. 3 bromo. That's the way we write it. Then what could be the name of CH3 substituent? It's methyl. Then what about the number? 4th carbon atom has methyl group. So therefore we write it like 4 short line and methyl. 3 bromo, 4 methyl. That is how we write the name of that given substituent. All right. Next thing. Now you see here, there is more than one type of ligand. One is Br, the other is CH3. There is more than one type of ligand. Then, how do we arrange them? One can write bromo first, one can write methyl first, but we can't say they are correct. Only one of them correct. Which one is then placed first? In that particular case, you consider what? Alphabetical order. Correct? That means you should know alphabetical order when you name organic compound. Yes, all of you know alphabetical order. It is not joke actually. But the thing is this one, I have seen this one. When we are doing classes in physically and check the answers, I have seen it. Although all of you know, I'm pretty sure all of you know the alphabetical order. But the thing is this, once you pay attention to the other rules, sometimes you forget that simple rule. I have seen that one. That's why I say you should know the alphabetical order. It is very important. Because there are a large number of rules here. Then you pay attention to those rules. In that case, sometimes you miss the most important rule. What is alphabetical order part? Right? Remember that one. So if you get more than one substituent, better you place them according to alphabetical order. According to that, you go to the name and first letter of the name. Look at this. B, bromo, and M, methyl. What is first? It should be 3 bromo first. 3 bromo. All right. Then what is the next one? We write it like 4 methyl. 3 bromo, 4 methyl. But again, a number and word, definitely you should use this type of short line to separate word and number. So therefore, this should be 3 bromo, 4 methyl. That's all. Okay. These are the rules to name substituent. But there is one more. There is one more rule in the case of actually this. What is that rule? What if you get another bromine in this carbon also? 6th carbon, you have again a bromine. Right. This is identified as a substituent. I take one example and all the possibility, then I finish that part. Hurry. What if you get another bromine attached to 6th carbon atom? What's the name of that one? That is then 6 bromo. That's also 6 bromo. Should I write then 3 bromo in one place, 6 bromo in another place, and 3 methyl finally, 4 methyl in another place? Then no, it's wrong. If you get more than one substituent, I mean of same type, if you get more than one substituent of same type, you don't write, you don't repeat it, you don't write same names in several places. According to the number, you have some prefixes. What are the prefixes? If you get 2, the prefix is di. 3, tri. 4, tetra. But in your syllabus, actually, maximum you get then 2. Therefore, di enough. But if you get di, then 3, tri, 4, tetra, 5, penta, like that. You have 6 hexa. You don't get these type of situations. But I give 7 hepta, 8 octa, 9. What is this? If there are 9, what is that? Nona or something? Nona, ne? It should be nona. Nona. And 10 deca. So now look at this. We don't write 3 bromo. We don't write 6 bromo. Instead of 3 bromo, 6 bromo, since there are 2 bromine, I use the prefix di. I use the prefix di. Therefore, this is not the name now, name of substituent, because I change it. So how do we write the name now? Okay, look at this. There are 2 bromine, so we write the name dibromo. Dibromo, but still B first. Because in the case of alphabetical order, when you decide the alphabetical order, you don't consider these prefixes. You get the first letter before you add the prefix. Before you add the prefix, you get the letter. That means not D. Here we consider what? B. We consider B, not D. So therefore, still B, bromo is the first one. Then dibromo. It is dibromo. But again, then once you look at this name, it has given dibromo, then you have idea, okay, then yes, there are 2 bromine. But do you have any idea about the positions? No. Then position should be mentioned. Position should be mentioned. But look at this one. If the prefix is di, how many numbers should be there? If the prefix is di, there should be 2 numbers. Maybe these numbers are different. Maybe these numbers are same. Doesn't matter. You should put 2 numbers. In this particular case, it is different because 3rd place you have 1 bromine. 6th place you have 1 bromine. Therefore, 2 numbers. 3, 6 dibromo. I hope you can see where I'm writing it. 3, 6 dibromo. But if I leave it in this manner, this looks like 36. Again, it gives some incorrect information regarding the compound. So then again, there is a rule. What is that? Once you put 2 numbers together, you should separate them. How to separate them? It's using a comma. It should be 3, 6 dibromo. There is a large number of rules here. One by one, I am explaining here. You can understand them, right? Then 3, 6 dibromo. Thereafter, you get only 1 methyl in 4th place. Then it should be definitely 4 methyl. 3, 6 dibromo, 4 methyl. That's everything regarding the substituent naming. I completed first part, names of substituents. Thereafter, I will complete the root name part. But before that, let's have the note also. I'm giving the note also. Let's continue the note. Write a step 4, name the compound. Write a step 4, name the compound. You wrote it, ne? Under that, we write down. Write it like this. The name of the organic compound. The name of the organic compound has 2 parts. The name of the organic compound has 2 parts. First one, names of substituents, and the second one, root name. First one, name of the substituent, and the second one, root name. First one, name of substituent, the other one is root name. Okay, then write again a subtopic, names of substituents. Names of substituent. I don't give everything to the note. I mean, These things you know, I mean, between a word and a number, you need a short line. You know that one. No need to write it. Ne? To separate two numbers, you need comma. Those things I will not give. Only the basic thing will be given. These things no need to write. Ne? First thing, names of substituent. Right. Then under that, let's write it like this. There are specific names. There are specific names of substituents. There are specific names of substituents. I'm not going to list out them here because you can see in the printed note, I have given that one, right? No need to write it. That is to save our time. There are specific names for names of substituents. The name of the substituent should be written. The name of the substituent should be written with the number of carbon, with the number of carbon atom to which the substituent is attached. Name of the substituent should be written with the number of carbon atom to which the substituent is attached. Then start a new point. Start a new point and write it. If there is more than one substituent, if there is more than one substituent, they are arranged according to the alphabetical order. They are arranged according to the alphabetical order. Next point. If there is more than one substituent of same type, if there is more than one substituent of same type, a prefix is used. If there is more than one substituent of same type, a prefix is used according to the number of substituents. According to the number of substituents. Okay, then you can copy these numbers and the prefixes. What did I say? A prefix is used, not suffix. Prefix is used according to the number. Just copy this: 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, like that. But you don't need all these, right? Okay, that's about then substituent note. That's all. Let's move to now root name part. What does root name contains? Once I explain that, we can go for nomenclature of compounds one by one. Substituent part is over, then root name. What does root name contain? I told you the name of the compound should give complete information regarding the compound. Name of the compound should give complete information regarding the compound. That means how many carbon atoms, what is everything, right? Okay, then substituent part is over. Then what else do you need to represent in the note, in the name? It is this way. First of all, in root name, we have the stem name. That means according to number of carbon atoms, there is a certain suffix. We call it stem name. Then we should write that one. Just after the names of substituent, we write the name of, the suffix due to the number of carbon atom. As example, 1 carbon, it's meth. 2 carbon, it's eth. 3 carbon, it's prop. 4 carbon, it's bute, not tetra here. Bute, or not but, it's bute. If there are 5, it's pent. 6, it's hex, like that. Maximum there will be 6 atom only actually, or very rarely 7, hept. Then 8 oct, 9 non, then finally 10 dec. I have given these a stem name, therefore no need to write anything. So that's the suffix due to the number of carbon atom. That's the name we write just after the name of substituent. So what is next order? Next one is this. If you get a double bond or triple bond, then suffix due to double triple should be placed just after the stem name. Okay. If the compound has double bond, you add the suffix like this. I mean, en. If the compound has a triple bond, you have the suffix like ine, yn. You see, these are very simple thing. Eh? The rules are very simple. All of you can understand, no issue. But the question is whether you drop any rules when you name the compound. Then you end up with the wrong name. Therefore, you have to make sure you apply all the rules when you name the compound. Normally, rules are something we try to break. We like to break rules, but that's the human nature. Here we can't go like that. Suffix due to double triple, Harry, in or ine. If it is not there, we can just skip this part, Harry. Finally, suffix due to the functional group. Suffix due to the functional group. Each and every compound has a certain functional group, then there is a suffix. As example, if the functional group, let's say this is aldehyde, this is the functional group available, aldehyde, then suffix is al. I'll give this one by one. If the functional group is, carboxylic acid like this, therefore the suffix should be oic space acid, like that. We write the suffix due to the functional group at the end of the name. Did you understand the order now? When you consider the name of, complete name of organic compound, first part is name of substituent, the other part is stem name, means the number, suffix due to number of carbon atom. Thereafter you have suffix due to double triple, and finally you have the suffix due to the functional group. Then complete name now there. That name gives complete information regarding the compound. Got it? Right. Let's complete this part also, the note. Write the subtopic root name. Subtopic root name. Since these are quite simple one, I discuss it quite fast. Root name. Okay, under that, let's write it like this. Under this part of name, first we write the suffix due to number of carbon atoms. First we write the suffix due to number of carbon atoms. First we write the suffix due to number of carbon atom. Or within bracket you can say stem name. It's there in the printed note, no need to write. Stem name. Then start a new point. After the stem name, the suffix due to CC double bond or CC triple bond, after stem name, the suffix due to CC double bond or CC triple bond is written. Suffix due to CC double bond or CC triple bond is written. Then better write it like this. CC double bond means ene. CC triple bond means ine. Those are the suffixes we write. Ene, ine. Right. Then again, start a new point. Again, start a new point and write, finally, the suffix due to the functional group is written. Finally, the suffix due to the functional group is written. Finally, the suffix due to the functional group is written. Right? No need to write the suffixes due to functional group, because now I'm going to take the functional group one by one, and given these suffixes, everything, we will discuss this further through the examples. That's what now I'm going to do. That is the last part of this. But I will take all the functional groups and at least 2-3 examples. Let's see, at least 2 examples under one functional group, and then discuss it. Then there will be minimum 28-30 examples like that. Then once we complete that one, you cover all the rules to name organic compound systematically. IUPAC name. Correct? Right. Now, I think you remember this order. Eh? What is the order? Name of substituent. This order is very important. Without that, you can't have them correctly. Name of substituent. Next one, stem name. Then double, triple. And finally, functional group. That's the order. Substituent, number of carbon atom, double, triple, functional group. That's how we place this. Let's go to functional groups. First, start with the simplest one. I mean, alkane part. That's the simplest one. Did you then learn these things in O level? Name in alkane? I don't think so. You didn't, eh? So you can't remember what you learned O level, eh? Some of you can't remember what we learned in last week. How can you remember what you learn in O level? Right, let's go to example and explain it. First of all, I take alkane, not only one class, I take alkane, alkyl halide, alkane and alkyl halide together. I think you will understand why I took alkane, alkyl halide together. For both of these two, due to the functional group, we add the suffix "ane." Then you know that when I mention it. Alkyl halides are not considered as a separate functional group in nomenclature. In nomenclature, we take them together. Together mean it is a derivative of alkane. That's how we take it. So therefore, due to the functional group in both cases, we add the suffix "ane." All right. With that idea, let's go to the example like this. Let's say you are given this compound CH3, CH2, CH2, CH3. All right. Identify the class alkane. Identify the main carbon chain. Only one chain available. That's the main carbon chain. Then number it. No need to number because there is no double bond. There is no triple bond. There is no substituent. Therefore, no need to number it. All right. Then okay. Then write the name. First thing, you arrange the names of substituent, but here there is no substituent. You can just leave it. Then you go to the root name. Under root name, first suffix due to suffix due to number of carbon atom. How many? 1, 2, 3, 4. 4, the suffix is but. Then add suffix due to double, triple. No. Last thing, suffix due to functional group. That's what given here. Ane. But plus ane, what is it? Butane. That's how we name this compound, butane. But plus ane, butane. Very simple. Then I take another example, alkyl halide. Let's say you are having like CH3, CHBr, CH2, CH2, CH3. This compound is given. Identify the class, alkyl halide. But in this case, nomenclature, We put "ane" suffix due to functional group. All right. Identify the carbon chain. Only one chain available. That's the carbon chain. Okay, then number in it. Then it is important because there is a substituent here. I told you, take Br as a substituent now. Then the minimum possible number, lowest possible number should go to substituent. Then it's clear. 1, 2 from this side, 1, 2, 3, 4 from this side. Then it's clear. Numbering is this. Correct numbering is this. Now I don't explain them in detail. Okay, then write the name. We have a substituent. Write the name of substituent first. That's the rule. So it is bromo, but in second place. So it should be 2-bromo. Right. Without leaving, go to the root name. In root name, first the suffix due to number of carbon atom, 5. Then pent. Then add the suffix due to double, triple. No. Always remember that order. Check everything. Double, triple. No. Then go to the functional group. Due to functional group, it's N. It is this. 2-bromo pentane is the name of this alkyl halide. Now I can discuss it quite fast because I explained the basic, the foundation well. You understood it. With that, now we can easily continue this one. That's how we name it. Okay. Then I will give one more. First of all, let's try this. Now next thing is, now I'm going to take all the functional group, all the classes one by one. Therefore, I think better now you go to, then the basic rules given in the printed note. Now we completed that one. Now better you go to the question book. In classes also, that's what I'm doing. We have a printed note. That is where we complete theory notes and everything. But for questions and all stuff, we have a question book, separate textbook. Now you need to use that book. Okay. Just textbook. Write the topic alkane, alkyl halide, and put this suffix "ane." Alkane, alkyl halide, and then put this suffix "ane." Thereafter, no need to write anything, no special thing. Everything we discuss. Just copy these examples. Example 1, example 2 with the names and everything. I give example 3. I'll give example 3 and try to name it. It's given CH3, CH, CH2, CH2, Br, let's say Cl. Always I take Br. That's my favorite. I take Cl. CH2, CH3. I took third one, quite advanced one. So since you are at the beginning, if you do mistake, completely okay. It's acceptable. But I give chance for you to name it. Doesn't matter whether it is correct or wrong. Okay, right. You need to write this topic, write this suffix, and then copy this example with the names and complete third one. Complete third one. I'll give only 1 or 2 minutes. Okay, I hope you completed it. Good, you did it, ne? Right. Right. Let's go to this one. Naming. First of all, identify the class. This is alkyl chloride, but we take that one as a substituent. Therefore, chlorine is easily identified as a substituent first. Right. Then identify the main carbon chain. There are several possible carbon chains, but then substituent. Now we give the priority to substituent. Therefore, your carbon chain should start from this carbon. It's one of N, so you can start it and come to this junction. Once you come to this junction, you can go to left or right, but left, no double, no triple, right, no double, no triple, left, no substituent, right, no substituent, left, one more carbon, but right, two more carbon. This is your main carbon chain. Now, other than Cl, this CH3 also becomes substituent. This is how then the compound becomes quite advanced slowly. That is another substituent. There are two substituents now, methyl and chloro. We know the names of this. Numbering. One can start from this end. It's 1, 2, 3, 4, 5. The green one. But the red one can be starting from this carbon. 1, 2, 3, 4, 5. That's the possibility. Those are possibilities we can have. But then what's the rule here? No double, no triple, no functional group, then substituent. Then substituent should have the minimum possible number. Now you see number 1 goes to the substituent here. And number 5 goes to substituent. It's okay. In this particular case, number 3 goes to the substituent. Both case, then number 3 goes to this substituent. Here number 1 and number 5. Then there are 3 options. 1, 3, 5. So which one is correct? 1. 1. That's the lowest possible number for the substituent. Because of that, in that particular case, remember, red one is correct here. Green one is wrong. Red numbering is correct. Green one is wrong. According to that, let's write the name of this substituent. So this one is then 1 chloro. First carbon atom has chlorine. According to red one, then this is 3 methyl. I asked you to first write the name of substituent. Then only you go to the root name. Then when you write the name of substituent, here there are 2 types. You see, one CH3 methyl, the other chlorine, chloro. Then alphabetical order. This is C here. This is M here. Then everyone knows alphabetical order. Chlorine first. 1 chloro. What is next? 3 methyl. Then I ask you to separate a number and word using a short line. So this is the way we get the name. That's the number of substituent. Thereafter, we go to root name. Under root name, we have suffix due to number of carbon atom. How many carbon atom? 5, ne? Total 5. 5 means I gave the stem name, pen. 5 means pen. Thereafter, suffix due to double triple. There is no double triple. Then suffix due to the functional group. It is ane. It is ane, pentane. So the name of this compound is what? 1 chloro, 3 methyl pentane. That's the correct name for this given compound. Okay. Right. I think those 3 enough to understand the rules and everything under alkane and alkyl halide. Copy third example also. We are going to move another 2 classes. I'll give more examples in a tute. I mean, homework sheet I will give, then don't worry. You can practice more and develop confidence. But to complete the rules, I take only these examples. This is enough, I think. Right. Any doubt you can have, you can ask. Let's move to two more functional groups, two more classes. Two more classes. These are the thing. Alkene, I take alkene and alkyne. I take alkene and alkyne together because there is some similarity. So that's why I take them together and explain the concept. Let's go to that quickly. If it is alkene given, the suffix you know already in. If it is alkyne given, you know the suffix already in. In, I. Then I take one example like this. Let's say you are given CH3, CH double, CH, CH2, CH3, like that. This is the compound given to be named. Okay, then how do we name it? First, go to the class. Always go back to first step and then come. Class, alkene, second, carbon chain. Only one carbon chain, that's the main carbon chain. Third, numbering. Is it important to number? Yes. In alkene kind, it is important to number the carbon chain. Why? Because the position of double bond should be specified. Position of triple bond should be specified. Then you have to number it. Green 1, 2, 3, 4, 5 means second carbon starts double bond. Red 1, 2, 3, 4, 5. Third carbon starts double bond. Then two options available. Number 2, number 3. Number 2, number 3. Then it's easy to decide. Lowest possible number, number 2. Then the green one correct, red one wrong. Then numbering part is also correct. Next, we name it. We don't see any substituent here. Remember, double bond is not substituent. Double bond is not substituent. Triple bond is not substituent. Always double bond, triple bond placed within the root name. I told you. Within the root name, you have suffix due to carbon atoms and then double, triple, then functional group. Therefore, double, triple not placed under substituent in any cases. Correct. Then no substituent here. Then we go to directly the root name. Root name, there are 5 carbon atom, then suffix is pent. Then we add suffix due to double. Yes, we have a double bond. Suffix due to double is what? In. But can I just write in? No. Position should be specified. In, position should be specified. Then you take the place. Second carbon atom starts double bond. Remember, always we put the number of carbon which starts double bond. Both number 2, number 3 belong to the double bond. These two carbon atoms, that is where you get the double bond. But you don't put number 3 here. We get the minimum one, the lowest possible one. Or in other words, number of carbon which starts double bond. Okay, pent plus 2 in. Then it is what? Pent 2 in. Easy. Alkane is pentane. Alkene is then pentene, but the position should be there, pent 2 in. This is correct. This one is correct. But there is another possible name for this one. Because if you get one number inside the root name, like, this is root name. Within root name, you have one number 2. Then you can take this 2 out. That's another possible way. You can take these 2 out, okay, 2. And then you can combine these 2 together. You take 2 out and combine these 2. Pent plus in, what is it? Pentene. Then you take 2 out and then combine them. It is pentene, 2 pentene. But again, the number and word, you should separate them. Don't forget it. This is also a correct name. In most cases in alkene, most cases, right? Not always. We can have 2 things. I mean, 2 names are possible. Okay, that's the way. Another example. If I take another example with substituent, you know how to do that one. I take like CH3. Let's take again triple bond. C triple bond CH. This is Br or something. You get CH2, CH2, CH3. I took quite a complex one. How can we name this complex compound? Doesn't matter whatever you are given, maybe complex, maybe simple, it's okay. You have to go back to the first step. What is the step one? Identify the class. What is it? Alkene. Alkyl halide is there, but I told you halogens we consider it as then substituent. Then it's not functional group. Then some triple bond. All right. Then main carbon chain. There are several possibilities, but functional group must be in the main carbon chain. Definitely we should start from this carbon and come to this junction. Where to go? Left or right? Then we should go to right. Why? Left you don't have double triple, right you don't have double triple, left you don't have substituent, right you don't have substituent, but left one carbon, right three carbon. You see how easy to get it? Once you identify it, this is also a substituent. So it's a triple bond alkyne having two substituents. Okay, then name it. But before that, you have to number it. Once you number it, you have several possibilities. 1, 2, 3, 4, 5, 6. Or the other possibility 1, 2, 3, 4, 5, 6. Then you can understand which one is correct, green or red. Which one is correct? Green, ne? Why? Our functional group is triple bond. Triple bond should have the minimum lowest number. Yes, number 1. If it is green, number 1 carbon starts triple. If it is red, number 5 starts triple. 1, 5. Easy option. Easy selection. Number 1. So that's why green is correct. Then the name of substituent. So what about this? This is 3-methyl. What about this? It is 3-bromo. Same carbon atom, but it's okay. You put the numbers. 3-methyl, 3-bromo. And then that question comes to our mind. We know we have to write substituents first, but then which substituents first? Easy. Alphabetical order. Bromo, B. Then 3-bromo first. We write it. 3-bromo first. Thereafter, we write 3-methyl. 3-methyl. Correct. 3-bromo, 3-methyl. Next, we go to the root name. Under the root name, what's the suffix? Same name. 6 carbon atoms mean it should be hex. It should be hex. What is next? Next thing is suffix due to double or triple. Hurry, we get a triple bond. Triple bond is there, but in this particular case, you know, the suffix should be then ine. Triple bond, then ine. But can I write just ine here? No, the position should be there. Green one, I told you correct. Therefore, first carbon starts triple, then it should be 1 ine. 3-bromo, 3-methyl, hex, 1 ine. This is the correct name. You know, up to this, it's name of substituent, thereafter root name. See the order, understand it, then it will be easy for you to continue this. Is there any other possibility? That's the next question you have, I know. Yes, can't we do the same thing as we did here? Yes, we can do. You know, this is root name. This part is root name. This part is root name. Inside the root name, you have just one number here, number 1. You can take it out of the root name. You can't take it here to the front. You can take number out of root name only. These things definitely should be written in same way. You can't change that one. But you can take one out of this. That's what you can do. So then you can write one hex and ion combined. This becomes what? Hexine. 3-bromo, 3-methyl, 1-hexine is another possible name. 3-bromo, 3-methyl, 1-hexine is another possible name. So if I am too fast, then let me know. I can slow down and then discuss slowly. But I think this is now okay. Okay, let's have the note regarding this. Copy this. Alkene, alkyne, ene, ion. You wrote it. Under that, let's write this rule. Simple one. You have to write it like the position of CC double bond or CC triple bond should be specified. The position of CC double bond or CC triple bond should be specified. That's the only rule here. Thereafter, you can copy this example. All right. That's the way we name alkene or alkyne. I think 2 example enough because we are going to talk about more example later. And then look at this one. So if you get 1 double bond, 1 triple bond, this is the way we name it. But I think this one, I didn't find any place. There was a very old paper, one structured essay question. There was one question to write the name of the compound having 2 double bonds. In that case, there is one simple rule. I take it as a third one, a special case. But in the recent past papers, I didn't see any question having 2 double bonds, 2 triple bond to be named. But it's a simple thing actually. So let's say you have 1 double bond here and again a double bond. This compound. I ignore the substituent part. I just forget. Here, then I wrote one thing. I mean, the position of double bond, triple bond should be specified. Another important thing is there. Better you write that one also. CC double bond or CC triple bond is not considered as a substituent. I have seen sometimes some student place ene ion under substituent part. That's completely wrong. CC double bond or CC triple bond not considered as substituent. Better you write that important point also. Hurry. So no substituent here. This is your main carbon chain. Numbering. You see number 1, 2, 3, 4, 5, 6, 7. Here. Number 1, number 2, number 3, number 4, number 5, number 6, number 7. Hurry. Then which one is correct? Green or red? You see, we have one double bond here. According to green, second carbon starts double bond. Red one, once you think about red one, just third carbon atom. Third carbon atom starts double bond. Green, second carbon starts double bond. Which one is good? 2 options available. Number 2, number 3. You can get it. It's easy. Then definitely green one is correct. Red one is wrong. Right. This is where now you have the new rule. Right. Then red one wrong. Green one correct. When you name first substituent, there is no substituent. If it has substituent, then same procedure. We name the substituent. Then since there is no substituent, I directly go to root name. Root name first in stem. That means 7 carbon mean we wrote it like hepne. So far we wrote it like hept. This is where we have a new rule. If you get 2 double bonds or 2 triple bonds, we don't write hept. We add a to that one. Therefore, not hept, we write it like, but hepta. If there are two double bond or two triple bond, we add a to the stem name. If there are four buta, if there are six hexa, if there are then five penta, like that, not hex, pent, but like that. Did you understand it? So this is the new part. A is added to the stem name. If the compound has more than one double bond or one triple bond, okay, then hepta, not hept, hepta. Thereafter, you write the name of double bond. In this case, ene. Here also we have ene. Should I write it like ene, two places? No. You know what to do. We discuss the same situation under substituent. If you get same substituent two places, then you don't write bromo-bromo. You take dibromo. Likewise, if you get two double bond, you don't write ene, you write di-ene. You write di-ene. But the thing is this. If it is di prefix, how many numbers should be in front of that? If it is di prefix, how many numbers should be in front of that? Two. What are the two numbers? Its second carbon starts double, fourth carbon starts double according to Green. So therefore it should be 2, 4 di-ene. 2, 4 di-ene. And hepta 2, 4, di-ene. That's a new rule you have. But in the case of last 10 years, you are given a question under nomenclature. None of them have then two double bonds or two triple bonds. But better you prepare for any situation. This is the one we have. This is something extra. Better you write that one also. Write this point. If the compound has more than, if the compound has two CC double bonds or two CC triple bonds, if the compound has two CC double bonds or two CC triple bonds, A, this one, A, is added to the stem name. A is added to the stem name, or simply A is added to the suffix due to number of carbon atoms. If you get two double, two triple. Okay, then let's copy this example. Let's copy this example. Right. Here you may have this doubt sometime. You may have this doubt. What is it? Can't we take both of these two out and then combine these? I ask you to take the number out of the root name and then write the name. Then here there are two numbers. Can't we take 2, 4 out and write heptadiene? No. That's why I say if one number available, not number one, just one number available, maybe one, maybe two or anything, just one number inside the root name here, then only you can take it out. Then only you can take it out. If two numbers are available, you can't take it out like 2, 4 heptadiene. No, it's wrong. Therefore, in this particular case only, this name is possible. There is no two possibilities. I don't know whether we wrote it. If you want, you can write that statement also. Write it like this. If there is one number inside the root name, if there is one number inside the root name, that number can be taken out of root name. That number can be taken out of the root name to write another possible name for the compound. To write another possible name for the compound. Right. These are the basic rules you should know regarding the nomenclature of alkene, alkyne. Then so far I completed 5 classes: alkane, alkene, alkyne, alkyl, halide. Only 4. Alkane, kene, kyne. Yes, only 4 classes we completed. There are about 10 more. Not 10 actually, less than 10. In nomenclature, some of them not considered as functional groups. Let's continue. Some of them then leave because, then if you can continue the classes like this, I mean, online or YouTube Live or whatever it is, only if you have a ability to focus for a long time, you can continue it. But some of you have then lack of focus, that ability. In that case, you can't continue it, then you leave the class. Maybe that is because this is available in the channel, so anytime you can watch it. But remember this one, then focus is essential in the case of learning, study part. One thing, attention. The other one is, sorry, not attention, alertness. First thing is alertness. The other thing is focus. Alertness means then before you start the class, before you attend the class, before you enter the class, you should give some message to your brain that you are going to start learning something new. Once you give this message to your brain, then it will be there will be a kind of preparation for the learning part. That means you give the message, then brain will be ready to understand or learn something new. You support. Alertness is that. It is really important. Okay, then no need to say it. I mean, you should give that message. You have to think about it. Even some people then doing these things, I mean, someone then have some habit like this. I mean, before they enter the class, they make the phone silence. They do it. In each and every class, before they enter the class, they make the phone silence. Then that's also alertness, right? If you do it always before you enter the class, that means that also a kind of alertness. The brain will take that message as kind of, okay, then he's going to, or she's going to start learning something new. I should be ready, like that. Then once you learn something new, then there is a kind of neuroplasticity happen in your brain, in neuron system. For that, there should be a kind of preparation. Brain and the neuro system should be ready for that. That's why alertness is important. Once you come to the class, then next thing is the focus. Without focus, I mean, you need a complete focus, laser focus to the teacher and what he is explaining throughout the class time, during class time. In that case, you have so many distractions, but you should be able to eliminate all distractions and have the focus only to teacher, maybe 2 hours, maybe 3 hours, even maybe 4 hours. It is essential in the case of learning part, study part. Right? So it's a skill, focus. It's a kind of skill you can develop. If you don't have then the ability to focus long time, then it's a kind of a skill you can develop. There are some exercises, there are some techniques to increase or develop the focus, that skill. Anyone can develop it. If you don't have that neuro development disorder, there is ADHD. It's a kind of neurodevelopment disorder. If you have that disorder, then you can't do this. Then you have to get the medicine from a suitable doctor. If you don't have that ADHD part, then HDHD, hyper attention deficient disorder or something. Yes, ADHD. Yes, I think ADHD. So then if you have that problem, then you can't do focus thing. But if you don't have that problem, then definitely you can develop your skill, right? There are some techniques to improve the focus. That is something essential in the case of learning part. I'll try to prepare a video for that one. What are the techniques? What are the exercises you can do to improve focus ability? Those who are having that one can stay all the time until the class is over. Right, let's go to another functional group. I take another set of functional group. I will explain why. I take now, what is next? Take amine, take alcohol, take ketone, amine, alcohol, ketone. Yeah, those are the three I take. Amine, alcohol, ketone together. There is one common feature here. That's why I take these three together. In the case of amine, the suffix due to the functional group is amine. This is the suffix. Alcohol, the suffix due to functional group is ol. Ketone, the suffix due to functional group is on. When these act as then main functional group, these are the suffixes you have. But sometimes these can act as even substituent. Amine means, you remember that NH2 group. Amine means NH2, but I write it like RNH2. What is R then? Then that is something I should explain. R is a kind of a common symbol which represent alkyl groups. Then you have again problem. What are alkyl groups? Alkyl groups can be derived from alkanes. Then you can't say what are alkanes. Definitely you know what are alkanes. Right? Alkanes is the one hydrocarbon which has only CC single bond. Right? If I take the simplest alkane, and the alkane, we will discuss this later. This is CH4. That's the simplest one. Second alkane, it's CH3, CH3. Third alkane, it's CH3, CH2, CH3, like that. These having only carbon, hydrogen, and only single bonds. Therefore, these are alkanes. I told you alkyl groups can be derived from this. How? Just remove one hydrogen. You remove one hydrogen from this. Doesn't matter anywhere you remove, you have alkyl group. Once you remove one hydrogen, it becomes CH3, but look at this. Valency of carbon, not satisfied. Valency should be 4, but only 3 hydrogen attached to this. Valency not satisfied. There is one missing part. Therefore, we put line like this. Anything can attach to this to satisfy the valency of carbon. Maybe it's halogen, maybe it's oxygen, maybe it's nitrogen, maybe it's sulfur. Whatever it can attach to satisfy the valency of carbon. Therefore, we represent that one like CH3 like this. if you take a hydrogen from this carbon in second alkane, what do you get? You have CH3, CH2. Then you see 3 becomes 2 because one hydrogen removed. And we put line, that's because something missing. Valency not satisfied. Here, you can remove hydrogen from this first carbon. If you remove hydrogen from this carbon, it could be like CH3, CH2, CH2 line, missing part. Or you can remove hydrogen from the middle carbon. That's also possible. If you remove hydrogen from middle carbon, what do we get? We get CH3, then CH. There were 2, but you remove 1, then it becomes CH, 1 hydrogen. And it has another CH3 group. I write it like this. And there is a missing part. That's also alkyl group. Okay. This side, what do we have? Alkane. You remove 1 hydrogen from alkane. So then you have what? Alkyl groups. Alkyl group. You can make alkyl group by removing 1 hydrogen from alkane. Therefore, alkyl groups are represented, I hope you can see, using capital R generally. Therefore, CH3 is one example for R group, alkyl group. CH3, CH2 is one example for R group, alkyl group. And these things are some other example for R group. I hope you understood it. How do we get the alkyl group? It's by removing 1 hydrogen from alkane, you can have alkyl group. What does alkyl group contains? Carbon and hydrogen only. Remember, R group contains only carbon and hydrogen. Then come back to this. If this missing part satisfied with NH2, if the valency, the remaining valency of carbon satisfied with NH2, we write it like RNH2. In the case of alcohol, that valence is satisfied by OH. In the case of ketone, that valence is satisfied by C double bond O, but both sides you have R groups. These R can be same or different, doesn't matter. These are another way to represent amine, alcohol, and ketone. You can use R part. Then what I'm trying to tell you is that sometime, if these are main functional groups, it's then amine, all on like that. But sometime you can take them as substituents. Substituent. This NH2 group is a substituent. Then what is it? It is not then amine. We call it what? Amino. We call it amino. This is when they are main functional groups. See the difference, eh? Substituent amino. Then our OH is considered as a substituent. Then what is it? It's hydroxy, not all. If it is substituent, I'll come to that later. In the case of this, actually, we take this only substituent as substituent. If ketone is a substituent, oxygen only, therefore we take the name oxo. In this case, these things act as substituents. I hope you understood it, but with the example only, you can understand it further. Now I explained 2 new things. One thing, R group, alkyl group, you understood it. Then I explain another thing. These functional groups sometimes can act as substituents when the compound has another functional group with high priority, like OH and carboxylic. What is the class of the compound? Last week I explained. Since the carboxylic has higher priority, it's carboxylic acid. Then OH becomes substituent. That is where you name OH using hydroxy. That is where you name using hydroxy. Sorry. These are the things you should know before we go to nomenclature of these things. I think you didn't write these things. Ne? Before that, better we go to this thing. Okay. Before we write these things in the note, let's go to these things first. Write the subtopic, alkyl groups alkyl groups, symbol is capital R. Write the subtopic alkyl group. Alkyl groups, capital R. Under that, let's write it like this. An alkyl group can be obtained by removing a hydrogen atom from alkane. An alkyl group can be obtained by removing a hydrogen atom from alkane. Alkyl group can be obtained by removing a hydrogen atom from alkane. Therefore, alkyl group has only carbon and hydrogen atoms. Alkyl groups have only carbon and hydrogen atoms. Okay. Then copy these things. Here the nomenclature also, I can complete the nomenclature also here. It's this way. How do we write the name? What is the suffix we use? Ane. We use the suffix ane to name the alkane. Then alkane, one carbon, no substituent. Then directly we go to root name, stem name, carbon one, meth plus ane, methane. The name of this methane, CH4. Correct? But when you name alkyl group, remember the suffix we use il, not ane. Alkyl group is named by using il. Then easy. One carbon, methyl. That's methyl group. Two carbon atoms. Two mean eth, no substituent, directly the stem name, then ethane. Then ethyl, you can understand it, easy. This alkyl group is what? Ethyl group. This is methyl group, this is ethyl group. According to that, you can see these things. This is what? Propane. There are three carbon, propane. What about this? Propyl group. What about this? This is also propyl group, but later I will explain this. This is taken like N-propyl. This is given as isopropyl, but don't worry. This is not a systematic way. It's a kind of trivial one. I'll explain why we put N, why we put iso later, right? Don't get everything together and mess up. I'll come to this later. Both are propyl because there are three carbon and alkyl group, but one is N-propyl, the other one is isopropyl. I'll explain that one later. Don't worry, just copy it. In the nomenclature of R groups, we use il suffix. That's the point. Right. That's about alkyl part. Thereafter you can copy this part. Amine, alcohol, ketone. And then show these things. I mean, the suffixes when it is main, how to represent these functional group using R symbol. Once these things become substituent, what are the suffixes? Amino hydroxyoxo. Then copy all these things. Okay. Let's talk about the rules to name these things. Let's talk about the rules to name these things. Correct? Okay, look at this. Here, one more rule is added. That's why I explained it. Other than the rules I explained, there is one more rule. Right, look at this. I take one example and explain. Let's take this one, CH3, CH2, CH, NH2, and CH3. This is the first example I take. How to name this one? Okay, go back to first step. What is first step? Identify the class. Okay, I identify NH2 functional group. Therefore, I identify this as what? Amine. Class is identified amine. This is the functional group. Then select the main carbon chain. No worry, this is the main carbon chain because only one option available. Then number it. Numbering is important because I will explain. This is number 1, 2, 3, 4. Green one, red one, number 1, number 2, 3, 4. You can even you can understand why I number it, because the position of functional group should be specified in all these three. That's one similarity. If there is amine, you should show the functional group, the position. If it is alcohol, you should show the functional group, the position. If it is ketone, you should show the position of functional group. Therefore, numbering is important. Next thing. Which one out of these two correct then? According to green, number 3 goes to functional. According to red, number 2 goes to functional. Then it's very clear. Red one is the correct one. Green wrong. Why? Functional group should have lowest possible number. Okay, that's also okay. Then do you find any substituent here? You don't find any substituent, because NH2 we already identified as what? Already identified as the functional group. There is no substituent. Right. Then directly we go to the name. This is where you have the new rule. No name for the substituent. Then we go to the root name. Under root name, what's the order? Stem name. I mean the name according to the number of carbon atom. Here, number of carbon atom 4. So far we got the name bute. So far we got the bute. Then remember this one. From this compound amine onwards. From amine onwards. When you write the name of the stem, I mean the name of carbon atom, suffix due to number of carbon atom, you add AN. You add AN to stem name. You add AN to stem name if the compound is a saturated compound. So many rules I told you. In organic, there is a large number of rules. We are learning the rules one by one under different classes. After amine onwards, any other compound I am going to explain, you can apply this rule. Right? So you add AN to the suffix due to number of carbon atom if the compound is a saturated compound. Only if it is saturated compound, you add AN. If it is unsaturated, you go back to the previous method. Unsaturated. Unsaturated means you don't add anything. I mean nothing. You add nothing here. You go back to previous method and then name it. No worry. But then you have problem. What is saturated, unsaturated part? Unsaturated mean you have the compound has CC pi bond. There is a pi bond between two carbon atom. That is unsaturated. Where you find pi bonds? We find pi bond in CC double bond or CC triple bond. Got it? Unsaturated means that CC double bond or CC triple bond available. Maybe one, maybe two. Simply carbon-carbon pi bond is available. That is where the compound is unsaturated. If it is saturated, no double, no triple. No pi bond between two carbon atoms. Now you see this compound is what? Saturated or unsaturated? That compound is saturated. Saturated because no double, no triple, no pi bond. Hurry. Then we have to add AN. It's not but. So far it's but, but now it is butane. So far it is but, but now it is butane. If there is a double bond, you go back to the previous method. I mean but. We don't add AN, but. If you get a double bond or triple bond. But here no, saturated. That's why we add AN, it's butane. That's the new rule you have from amine onwards. Hurry. Thereafter, we go to the next suffix. Suffix due to double, triple. No, not available. Then suffix due to the functional group. Then main functional group. Amine. Amine. Can I write just amine? No. We can't write just amine. The reason is in these three classes, that's the similarity. In these three classes, position should be specified. In these three functional groups, position should be specified. NH2, you know, position is number 2 according to red one. So therefore, butane to amine. So I'm explaining this in detail. It seems like large number of rules, but it is not, right? Once you practice several and develop the confidence, this is nothing. Very simple one. Butane to amine. But again, you see, this is root name. Inside the root name, you have one number. Then it is not new rule. You have one number, you can take it out. The butane to amine can be taken like 2 out, then 2 butanamine. Both ways are correct. Butane to amine or 2 butanamine, both ways are correct. That's the thing you should know under amine, alcohol, ketone, in all the three. But once I go to alcohol, only difference is instead of amine, you get all. Once I go to ketone, only difference is instead of amine, you get all. All the other rules are same. Okay, I hope you completed this part. Thereafter, write these points then. Write these points. Write it like this. The position of these functional groups, should be mentioned in the name. The position of these functional groups should be mentioned in the name. Should be mentioned in the name. Next one. Next point. From amine onwards. From amine onwards. AN is added to AN. AN is added to stem name. AN is added to stem name if the compound is a saturated compound. AN is added if the compound is a saturated compound. Within bracket, write no CC double bond, no CC triple bond. No CC double bond or CC triple bond. Saturated means that simply no carbon-carbon pi bonds. It is easy to write in that manner. Let's write within bracket, write no CC double bond, no CC triple bond. Got it? Hurry. Those are the rules for these three. Then you copy this one. And thereafter, I give this one also to name it, try to name it. This one, CH3, CH, I take Br again, and CHOH, CH3. How to name this compound? Second one. First, you copy first one and then try the second one also. Okay, I think the time is enough. I hope you tried. Once you get the idea, you can easily do it quite fast. But here I am slow because there are some people who can't understand if I go very fast. Okay, identify the class. First thing, class alcohol, alkyl halide, but priority alcohol. So I identify this as alcohol. Then OH is the functional group. Identify the carbon chain. This is the only carbon chain available. That should be the main carbon chain. Numbering. If you go from this side, 1, 2, 3 goes to sub main functional group. 1, 2, 3, 4. If you start from the other end, you get number 1, 2, 3, 4. Now Br is substituent. Halogen is substituent. Br is substituent. Now look at this. So what is the correct numbering? Green or red? It should be green. Why? Functional group has number 2, number 3, two option. Number 2, number 3, lowest possible. Then 2. Therefore, green. Correct. Red wrong. That's okay. Then the substituent. We have a substituent here. Therefore, we name it 3-bromo. Now we are ready to give the name of this compound. First of all, we write the name of substituent, bromo first. Then we write 3-bromo. That's all. Just one substituent. This is not substituent, OH, functional group. Then we go to the root name. Root name. Then don't forget that rule. Root name. Root name. First we write a stem name. That means number of carbon atom. Suffix due to number of carbon atom. Then I ask you to add AN if the compound is a saturated one. As you can see, this compound is saturated because there is no carbon-carbon pi bond, no double bond, no triple bond. Therefore, this is a saturated compound. Saturated means you should add AN. So in that particular case, for then you should add AN, means butane. 3-bromo butane. After that, suffix due to double, triple, no. Then suffix due to functional group, okay. Alcohol, alcohol main all. But we can't just write all. Why? I told you in these three cases, the position of functional group should be specified. Where you find all? You find in second place. Green one correct. Then according to that, it's second place. 3-bromo butane to all. 3-bromo butane to all. That's the name. Is there any other name, other possibility? Of course, you see, this is your root name. Inside the root name, you have one number, then you can take that out of the root name. That number you can take out of the root name. Okay, then write it. 3-bromo. We took 2 out, then 2 butanol. Both ways are correct. Butane to all, 2 butanol. Both ways are correct. Okay, no any doubts regarding this. It can't be because I explained that in detail. So if it is ketone part, you know, only difference is instead of all you have all. Everything else same. But now I take one more example and show you what if it is unsaturated compound. These two saturated, that's why you add an suffix and write the name in this manner. But what if you are given unsaturated one like CH3C, you have double bond O, CH2, CH double, CH2, this way, this compound. Let's add a substituent also. Let's take I. This is the compound you are given to be named. But first you identify the class of the compound. For that, we need the functional group. We see functional group this. Then we identify this as ketone. Halogen available. Then if halogen available, you identify this as a substituent. Follow this order, then you don't do any mistake. You end up with the correct name always, right? Everything okay. Then main carbon chain, only this one available. Thereafter, we go to numbering part. Yes, you have to number here because they have different numbers. I mean, 1, 2, 3, 4, 5. Then you have 1, 2, 3, 4, 5. Okay. In this case, you know, this compound has a double bond. This compound has a substituent. This compound has a functional group. Which one do you consider first? You consider first double bond, you consider first substituent, or you consider first functional group. In the case of numbering, definitely functional group. According to red, number 2 goes to functional. According to green, number 4 goes to functional. Then no need to worry about the substituent. No need to worry about even the double bond because you give the priority to functional. According to that, 2 or 4. Two options available. 2 or 4. Lowest possible number 2. Red correct, green wrong. Sometimes some of you think double bond first and take green one correct. They think double bond should have the lowest possible number, but no, before double bond, you should think about functional group. Then only you go to double bond. According to functional group, then red one is correct. Hurry. Numbering is okay. Then last step, then write the name. You know, this is substituent, then write the name of substituent first. So it should be 3 iodo, iodine, you know, iodo. That's all, substituent. Then we go to root name. Root name means the stem. 5. Then look at this. What do we write here? There are 3 possibilities, you know. So far I explain it. Pent, penta, pentan. Do you remember this? All the 3 possibilities I explained already, right? Pentan, it's clear. Pentan, if the compound is saturated. But only after amine and only after amine we do that. We don't apply these things for alkene kind, alkyl halide. We apply after amine, right? Hurry. Then pentan, if the compound is saturated. Is this saturated? No, because double bond available. We have a pi bond between 2 carbons, so it's not saturated. Penta. Where did I add penta? A. You get 2 double bonds, 2 triple bonds. That is where you add A. Do we have it? No, we don't have. We have 1 double bond. Therefore, it's not penta. Then it should be what? Pent. It is pent. You see, once you understand it, it's easy. Pent. You don't do any mistake here. Pent. Hurry. Okay, that order there, right? Suffix due to the number of carbon atoms, stem. Thereafter, you get suffix due to what? Double, triple. If available, we should go to double, triple. Do you have double, triple? Yes, we have double. Then you have to put that one next. Hurry. So what is it? Ene, double bond, ene. But according to red one, its 4th carbon starts double bond. It should be 4 ene. It should be for ene. And then finally we go to the suffix due to functional group. What is functional group? Functional group is ketone, then suffix is what? -one. But in ketone case, in all these three cases, position should be specified. Then in that particular case, where do you find ketone part? Then second place. Therefore, you put 2-on. 3-iodo pent 4-ene 2-on. But look at this. I follow all the rules and end up with this one. But the answer is not correct. Name is not correct. Then I introduce another rule. Okay. Don't worry then. I think no more rules, right? No more rules. Yes. This is the last rule, I think, the special rule. Under ester, we have some special cases. Until then, you don't have any other rule. This is the last rule. Then happy about that. Now I can imagine your face. This is the last rule. What is the rule? If you add another suffix after ene or ine, if you add another suffix after ene or ine, drop this last e. Ene or ine. After ene or ine, you add another suffix. Drop this e, last e. Then write it. What is this? 3-iodo pent 4-ene. En only. En, not ene. In alkene, you put ene, but after that, we don't put. Why? In alkene or alkyne, you put the last e. But in these cases, you add another suffix after this, then you drop the next last e. Then 4-ene and 2-on. This is the correct name. This is the correct name. Right. Then you may have this problem. Now you have several numbers inside the root name. Can't we take it out? Yes. Then you can say, no, there are two numbers. Right. If you get two numbers together, you can't take both numbers out. If you get two numbers together, like 4-3 like that, 3-4 like that, you can't take 3-4 out and then write it. But you get here number like this, 4, then ene, and then 2 and on like that. Total number of numbers, yes, it is 2, but it's not together. In this case, you can take the first number out of root name. You can take 4 out of this. Then pen 4-ene can be written like what? 4-pentene. You can't take both 4 and 2 and write pentene on like that. No, only the first number you can take it out of the root name, right? Then it's 3-iodo. You took 4 out, then pen 4-ene, then 4-pentene. No e after n. Thereafter, you add the other part 2-on. This is also correct name. This is also correct name. Then, yeah. In the case of rules, 95%, I can say like that, yes. 95% of rules now finished using these classes. Alkane, kene, alkyne, alkyl halide, and these three, yes. In these cases, then we completed about 95 rules. I think I gave you the note regarding this AN part, where to add AN. I think we wrote it. The position should be specified and everything. I think I wrote. But this one is something new. Better we write that one also. Write a point like this. After ene or ine, after ene mean ene, after ene or ine, yne, after ene or ine, if another suffix is added, if another suffix is added, the last E should be dropped. The last E should be dropped or omitted. In last E means this one. This should be omitted. In ein, last E means this one. This should be omitted. Only if you add another suffix after in ein, you drop the last E. That's another new rule we have. Okay. Better you copy this. These things, then no need, you don't have to take it note. I mean, if you have two numbers in two places inside root name, the first number can be taken out. Oh, you can remember that. Okay, copy these things. This example, third one, with the names. Okay, I hope you got it. Shall we go to another set of functional groups? Yes, let's go to some other functional groups. Here then I take the examples to explain the basic thing. Then other possibilities, I will add that one to the homework sheet. Then you can practice as example. You know what to do if two OH groups available in the compound. You know what to do if two NH2 groups available. Two OH groups available, then diol. And with the position. 2,4-diol like that. If two NH2 groups available, then diamine. Then I don't discuss that here, but I will add that one to homework sheet and then explain that one. Next thing, there is another possibility like in NH2, hydrogen can be replaced with alkyl group. But those are those things will be discussed under amine physical and chemical properties. Primary amine, secondary amine, tertiary amine, then how to name it. I'll come to that later. But these things enough to do the past paper thing. Shall I take 4 more functional groups? Not 4. Let's take these things. Ester I take separately. I take aldehyde. Next, amide. Next, acid halide. Yes, so acid halide. And finally, carboxylic acid. Carboxylic acid. Why I take all these 4 together? Because there are some similarities. That's why I took them together. Right, look at this. Once you consider these things as main functional groups, then suffixes are these things. Aldehyde, the suffix is al. Amide, the suffix is just amide. Acid halide, the suffix is oil space halide. There is a space between oil halide. But halide is the common thing. If you have Cl, then chloride. If you have Br, then it's bromide, oil chloride, oil bromide, like that. If it is carboxylic acid, if it is main thing, it's a oic space acid. Oic acid. Between oic and acid, you have a space. These things, when you consider the functional groups as then main functional groups, these are the main functional groups. But there is another possibility. I mean, I take an aldehyde like this. This is the way now represent aldehyde. RCHO. R, you know, I explained, alkyl group. Amide can be represented like RCONH2. Acid halide can be represented like R, C double bond OX. Carboxylic acid can be represented like R, COOH. Okay. Now, this is a substituent. Sometimes these groups can be a substituent. This can't be substituent carboxylic because according to our syllabus, this has the highest priority. So if it has highest priority, then it can't be then a substituent. If this is substituent, the suffix is formyl. Different subs, you know that. This is, if this is substituent, it's carbomoyl. If this is substituent, it is haloformyl. Haloformyl means if it is chlorine, chloroformyl. Bromine, bromoformyl. Here there is no suffix because it's not act as substituent. When these act as substituent, these are the suffixes. Okay. Almost we finished this one. Then, although it's difficult, just stay with me. Let's go to one example. I take like this: CH3, CHOH, CH2, CHO means aldehyde. I take. This is the first example. Now it is easy. These four actually very easy because you remember I gave 5 classes. In these 5 classes, it is very easy to identify the carbon chain, right? Because carbon chain should start from the functional group. I told you. It is very easy to number the carbon chain because I told you numbering should start from that functional group. 1, 2, 3, 4. In those 5, remember that one, right? Here only one missing. It is ester. Sorry. Then 1, 2, 3, 4. Then what about OH group? Look at this OH group. In the previous set, I gave one example. In that case, I consider OH as a functional group. But now I consider it as a substituent. You know why? Because I identify the class as aldehyde. You have 2 functional groups, aldehyde and alcohol. But according to priorities, I identify this as aldehyde. Once you identify aldehyde, this is functional group, not this. Therefore, this becomes now substituent. That is where you need that hydroxy suffix. I think now you got the idea, ne? You get all when OH is functional group. But if it is substituent, you get hydroxy. That's the meaning of these things also. Hurry, then write the name of substituent first. It is 3-hydroxy, one substituent available. Then without leaving space, you write the name of root name actually. In root name, first thing is the suffix due to number of carbon atom. There are 4. Now look at this. 4 mean there are 3 possibilities. But, buta, butane. What is correct one? Buta, butane. What is correct one? We discussed that in detail. You remember that, ne? Buta, butane. You know this. This is, it can't be but because the compound is saturated. But, I told you, from amine onwards, but. We use that one for unsaturated one. This is saturated because no pi bond. See, pi bond, no double, no triple. In that case, we add Butan, AN should be added. Buta, A added if there are two double bond. No, no case. No, we don't have any other situation like that. So therefore it should be butan because it is saturated. Butan. Thereafter, suffix due to double, triple. No, there is no double, no, there is no triple. Then the suffix due to the functional group. What is functional group? Aldehyde. If it is aldehyde, functional group, the suffix is al. Hurry. Then there is a problem. Should we write the number? Should I write 1L? Then that is the similarity in these four functional groups. You should not write the number 1 in front of L. Because you remember I told you, in all these four, definitely the carboxylic acid carbon is number 1. Acid halide carbon is number 1. Amide carbon is number 1. Aldehyde carbon is number 1. If these are the functional group, main functional group, number 1 goes to that one. Therefore, no need to put number 1 here. But in previous case, alcohol, OH, can we say it's definitely number 1? No, OH can be anywhere in the carbon chain. Got it? So therefore, here no need to write 1. You just add. So what's the name? 3-hydroxy butanol. 3-hydroxy butanol. Okay, that's the common feature here. 3-hydroxy butanol. In these cases, in front of this, we don't write the number. But when they are substituent, definitely we write it. Definitely we write the number. Okay, let's point out that one. First, copy this aldehyde, amide, acid halide, carboxylic, and copy all these suffixes and everything. I hope you copied it. Under that, write this rule. It's not a rule actually. Rule mean then, no, it's a rule. Yes, write it like this. In these four functional groups, or in these four classes of compound, in these four classes of compounds, the number of carbon atom, in the functional group, within bracket write 1. They have always number 1. The number of carbon atom in the functional group within bracket 1, close bracket, should not be mentioned. Should not be mentioned in front of the suffix due to the functional group. Should not be mentioned in front of the suffix due to the functional group. Suffix due to the functional group. Okay, then copy this example and try to name this compound. Like you get CH3C, CH2NH2, CH2, C double bond O, Br. How to name this type of compound? Copy the first one and try the second one. It's okay whether you cannot name it correctly because we are at the beginning. Sorry, I hope you tried it. Because of the time problem, only 24 minutes available. Ne? Okay, look at this. Go back to first step. Don't forget these things, the order. Step one, identify the class. We have COBr, it's acid halide. So we identify this as acid halide. One can say, no, NH2 available. Can't it be amine? No, it can't be amine. Why? Priority goes to acid halide. Then NH2 group is a substituent. This is a substituent. Identify carbon chain. It is easy because in these classes, I ask you to start the carbon chain from this carbon in the functional group. Come to the junction. Once you come to junction, two options, down or straight. First, you consider double, triple. Down, no double, no triple. Straight, no double, no triple. Second, you consider substituent. Down, then you meet one substituent in NH2. If you go down, you have one substituent. You meet one substituent. But if you go straight, there is no substituent. What should I do? Go straight or down? Since you meet another substituent when you go down, yes, of course, you go down. Eh? And this is your main carbon chain. Once you identify this, you see CH3 group is another substituent. CH3 is another substituent. All right. Next, you need numbering. Numbering again easy because I asked you to start from the carbon in these functional group. In these four, we can do it like that. 1, 2, 3, 4. That's the correct numbering. That's the correct numbering. Okay, then let's identify this substituent. This is 4-amino. Thereafter, it's easy. This is 3-methyl. And now look at this. It's not 4-amine. It is amino. Why? Because NH2 is a substituent here. When NH2 substituent, it's amino. Only if it is functional group, it is amine. It is amino. 4-amino first. Okay. 4-amino. What is next? 3-methyl. Hurry. Thereafter, go to the main carbon chain. How many carbon atoms? 4. In root name, first we write the name, stem name. 4 means, what do we write? Then here I was to actually introduce double bond, but I forget. Here, no double, no triple means saturated. Saturated means you have to add AN, butane. AN, butane. Thereafter, we write the suffix due to double, triple. No, not available. Then suffix due to the functional group. What is it? Acid halide, the main functional group, oil space halide. Oil. Should I put number 1? No. In these 4, I told you, no need to put number 1. Then it is oil space halide. Here we don't write halide. Halide is the common thing. Here you see bromine is available very clearly. So therefore space bromide. Bromide. Not halide, bromide. 4-amino 3-methyl butanoyl bromide. 4-amino 3-methyl butanoyl bromide. Let's go to one more where the compound is unsaturated part. I'll give one more where the compound is unsaturated part. Once you get double or triple, how to name these things? Okay, then look at this. I take this compound. Third one, this is the third example. Let's say you have CH3, CH2, CCOOH. This is how it's given. Sometimes they give the displayed formula. You have to be careful. Then Br here, CH double. Let's take triple, C triple and CH or CH3. This is exam standard question. These are the type of question you are given in exam. So in this case, how do we name it? Just think about it. I will give you about 1 minute. Thereafter, I will explain. Hurry. So here, you know, then now, yeah, we are very close to the end of the class. Then 3 hours class I arrange. Then I got the 100% benefit. I mean, the advantage of these 3 hours, right? Without wasting any minute. We discuss everything within this 3 hours. Because if I discuss some other stuff, then definitely we won't be able to finish this one within these 3 hours. That's why I didn't do it. I hope you are okay with that. Step 1, identify the class. Class is okay, carboxylic, COOH, we identified. Identify the main carbon chain. Then I ask you to start from that carbon always. In these 4 classes, not 4 actually, 5 classes, we start from that. Once you come to junction, where to go? Triple bond available, then go to right hand side. So this is your main carbon chain, right? You identify Br as a substituent, this whole group as a substituent, right? Numbering, don't worry. Go back to functional group carbon. Number 1, number 2, 3, 4, 5. These are the 3 steps. Identify the class, main carbon chain, number it. Okay. Thereafter name. This is substituent. The name is 2. Second carbon atom has bromine, then 2 bromo. What about this substituent? Do you remember that? 2 It's alkyl group, CH3CH2. CH3CH2. 2 carbon mean eth. Alkyl ethyl, it's 2 ethyl. Not 2 ethane or something, because CH3CH2. CH2 mean alkyl group. 2 carbon ethyl. Correct. Arrange them according to alphabetical order. That's the next one. It's very easy. 2 bromo. Hurry. Next, 2 ethyl. Okay. That's all. I mean, the substituent. Thereafter, root name. First suffix due to number of carbon atom. There are 5. Triple bond is there. That means the compound has CC pi bonds. What should I do? I mean, pent or penta or pentan. Definitely, it's pent because it's unsaturated. Saturated only we add an, pentan. If there are 2 double bonds or 2 triple bond, only we add a, penta. But only 1 double or 1 triple, it's pent. That's the suffix due to number of carbon atom. Thereafter, the order, remember order, now, suffix due to triple, ine, but there is number 3 ine. Then and the next thing I told you, after ine, we need to add a suffix due to functional group, oic acid. In that case, I ask you to omit last E. Don't forget these rules. We omit that one. We ignore, we neglect that one. So then we add oic acid. Should I add a number 1 to oic acid? No. In these 5 classes, I ask not to mention the number. Then it is oic space acid. In other classes, then we should mention even the number 1 comes OH in first place, number 1, definitely you have to mention it, 1 whole. But in these 5 classes, I told you no need to mention number 1 because it's always number 1. All right. And then look at this. 2 bromo, 2 ethyl, pen, 3 ionoic acid. That's the IUPAC name. Then one can have this doubt. Can't we write another name? Yes, of course. When you check the root name, you have one number inside the root name. You can take that number out of the root name. Then 2 bromo, 2 ethyl, 2 ethyl, yes, 2 ethyl. And 3 comes out, 3 pentinoic acid, like this. Pent 3 ionoic acid or 3 pentinoic acid. That's what happens if you get double or triple with these functional groups. Right. Let's go to the last class. Here then, I didn't, let's talk about this. Last one is ester. Yeah, I didn't explain ether part and nitrile part. Under the trivial name part, I will explain it. I mean, then I told you I will arrange another class that is to discuss the questions. That is to develop the question. Right? In that class, I will take about 30 minutes and explain trivial name part. Under that, I will explain that ether part and the nitrile part. But these things enough to answer any of the last 10 years questions. Ester. Ester, the functional group, maybe you remember, I can represent that in this manner, R, C, O, O, R. But I take it like R dash. R means what? Alkyl groups. One example, then me, CH3, CH2, CH2, C double bond O, O, CH3, like that. Then what about CH3, CH2, CH2? It's an alkyl group, R. What about CH3 group? Another alkyl group, R. But I took R, R dash because they can be similar, sometimes they can be different. That's why I put R dash here. Right. When you write a name of ester, according to the functional group, the suffix is OAT. OAT. The suffix due to functional group is OAT. But these rules are quite different from the other functional groups. Okay. Once I discuss this, then 100% rule be completed. In esters, first we write, in the previous cases, always first we write what? Substituents. Here, it's not substituent or anything. First of all, we place the name of this R dash. That's what we first place. Let's say the general name, I write it like alkyl. Then when you write the name, first we write that one, alkyl. Then leave a space. Thereafter, you identify this one as the main carbon chain. This is what you identify as main carbon chain, main alkyl group. Then OAT is added to this part. OAT is added to this part. But I take it like, generally I write it like alkanoate. Right? This is general name, alkyl space alkanoate. What is alkyl part? This one, R dash. The one which is separated from oxygen. The one which is separated from oxygen is written here. Then leave a space, go to the main carbon chain and add OAT for that one. That's a rule. Okay, look at this ester. I'm going to apply this rule here. Once you are given ester to be named, first identify that R dash part, means the isolated one. The one which is separated from oxygen. Which one is separated from oxygen? Then this one. It doesn't mean that R dash always placed in right. Sometimes it is placed in left also. As example, if the compound is given in this manner, CH3O, C double bond O, CH2, C, Br, CH, CH3 or something. Here, what is, then I take CH2, CH3 like that, this one. First of all, identify R dash part, the isolated one, the one which is separated from oxygen. What is it? Look at this. C double bond O always belong to the main part. Then this is what separated from this is what separated from oxygen. That is the isolated one. Here, this is R dash. That's what I told you. That there is no rule to place R dash always at the, right hand side. Sometimes you can have it in left also. Identify R dash. Okay, we identify how many carbon? 1. Then alkyl. It's an alkyl. What is the name of alkyl with 1 carbon? It's methyl. We just write it methyl. Leave a space. Here, how many carbon atom? You see, it's alkyl but 2 carbon. Then ethyl. That's what we first write. Whether substituent available or not, this is what we write. Then leave a space. And then we see whether the substituents are available. In this case, I told you this is the main carbon chain, number 1, number 2, number 3, number 4, but there is no any substituent or double bond, anything. Here now, carbon oxygen double bond, number 1, number 2, number 3, number 4. Do we have substituent? Yes, we have substituent. Here we don't have substituent. Then you just write the name with OAT suffix. Then what's the name of this? 1, 2, 3, 4. But. Butane. Which one is correct? Here also same rules applied. It should be butane. Why? No double, no triple. Saturated. Butane. And then we add suffix due to double, triple. No. Suffix due to functional group. OAT. Should I add number 1? Should I represent number 1? No, I told you. You remember the 5 classes? Ester is one of them. Always number 1 for ester carbon. So no need to mention number 1. So the name of this ester is methyl space butanoate. What about this? Here we have substituent. How to name it? Then substituent should be attached to this main part. Here there are again 4, then butane because saturated. But before butane, we should attach this substituent. Actually, it is what? 3-bromobutane. And suffix due to double triple, no. Then because of O8, ester, it's O8. Should I add number 1? No. This is 3-bromobutanoate. That's how we name ester. If you get double bond, you know what to do there. Same as the previous. But let's say third carbon atom has double bond, then 3 ene, last E dropped, and add O8 without adding number 1. Okay. Then the other thing, in the previous cases, I told you the number and a word should be separated by using a short line. But in this case, it is space. Rule is the space between these two parts. Therefore, never put then a short line here. That's wrong. It's space. Ethyl 3-bromobutanoate. That's the way we name ester. That's the end of rules to name any organic compound. Okay, put ester and O8 and copy this part and then write it like this. Copy this part. All right, under that, let's write it like this. In esters, first we name the alkyl group which is separated from oxygen. The alkyl group which is separated from oxygen. Separated from oxygen. Next point. The suffix due to the functional group is O8. The suffix due to the functional group is O8. The suffix due to the functional group is O8. And it is added to the name of the other main carbon chain. It is added to the name of the other main carbon chain. Main carbon chain has this part, C double bond O part available, belong to main carbon chain. Next point. Since ester takes number 1, since ester takes number 1, to the carbon in the functional group, since carbon ester takes number 1 to the carbon in the functional group, 1 should not be mentioned in front of O8 suffix. One should not be mentioned. One should not be mentioned in front of oate suffix. Okay, those are the rules. Then copy these two examples. Example 1 and example 2. I'll do one more with double bond. Thereafter, we can finish this part. Let's say you have CH3, COH, NH2, CH double, CH, C double bond OO, CH3. This is given. These are the exam standard one. Okay, in esters, first I ask you to identify R dash. R dash means the one which is separated from O. This is R dash. This is the one which is separated. Not R1, it's R dash. Then this one is the main carbon chain. I told you number 1 goes to this CO first, then 1, 2, 3, 4, 5. That's the numbering. These things I see as a substituent, OH and NH2, because ester has higher priority than NH2OH substituent. Then I asked you to name this first. Yes, substituent available, but we don't write them. First, we write this R dash. Okay, so what's it? 1 carbon, alkyl, methyl, leavers phase. Now you have substituents. 2, 4 amino. The other 4 hydroxy. Then amino first, alphabetical order, 4 amino. Then 4 hydroxy. Hurry. What else? Then suffix due to the number of carbon atoms, stem 1, 2, 3, 4, 5. Now you have this question, pent, penta, pentan. Then you have the answer itself. What is it? Pent. Because it is unsaturated, double bond available. So it's pent. Hydroxypent, hurry. Thereafter, suffix due to double. Yes, we have double in second carbon. So it should be 2 ene. Now I don't write the other E. I dropped it. You know why? Thereafter, we should add OH suffix. Then suffix due to functional, OH. Should I mention number 1? No. Then we just add OH. You see? That's the name. Methyl, 4 amino, 4 hydroxypent, 2 enoate. Pent, 2 enoate. E. Right. Again, I think you noticed that. Can't we have another name? Of course, because this is your root name. Inside the root name, you have one number. Then you can take it out without any doubt. Therefore, there is another possibility. Other part, no change. 4 amino, 4 hydroxy. This is where you take 2 out. Then it should be 2 pent 2 enoate. It's 2 pentenoate. Both of these two names are possible for this. This is correct. This is correct. Pen 2 enoate and 2 pentenoate. Okay, then I promise you to finish the nomenclature part within 3 hours. Yes, I did it, but I told you then With this knowledge, actually, then there are two type of question. One thing, structure given like this, you are asked to write the name. There is another question, name is given, you are asked to write the structure. But with this knowledge, you can do that question also, doesn't matter. Next, that ether and nitrile part, I discussed that under trivial name. Within 30 minutes, we can finish that part. Then I promise you to arrange another class, that is to complete that trivial part, mainly the question discussions. Before that, you have to go through this again, study properly, have a good confidence. Then only you can try the questions, and then only you can participate that class. Sorry. Yeah, I will arrange another live then about 2 days ago. I mean, for the next class, 2 days prior to the 2 days prior. Then I will arrange the online class, and in the description I will put that homework sheet. Then 2 days enough, ne? Yes, of course. Then you can take homework sheet to complete it, then participate live. Those are mainly for the question discussion. Then that's the completion of this nomenclature and introduction topic. Right. Then I hope you enjoyed this. Ne? Thanks. You wait until the end and support me. We will meet in the third live. That's the last live for nomenclature part. Okay. I'll arrange another live for chemical and physical properties. Sorry. Then that's enough, Nick. Good night. See you next day.